We've seen the ability to go into the public cloud and to scale very rapidly based off of what is effectively commodity infrastructure. In the similar way that we have, a power grid and we just plug into power, now we can do that with our compute, with our memory, databases, whatever. And as part of that, it's caused us to have to reevaluate how we think of systems. Back in the day, if you had a, into-your web app or whatever, you had to go put it on a server. And if you wanted to get more of that into-your web app, then you would have to go get another server and put it next to the first one. And now you have two servers. And so we designed things as monoliths. But as we've seen the rise of sort of commodity infrastructure, commodity software, then we've decomposed our systems a bit. And now we have all these different parts that all have to talk to each other. Kubernetes obviously has also accelerated this, right? Where we have various different Kubernetes pods and workloads running. And we've also started to think of like, oh, wait, the people that actually manage these systems are also kind of important, because if the people don't know what's going on in the system, then we can't fix the system. And I like to think of systems, almost like this, and not as planets, but the ring around the planet, right? You think about, what is that ring composed of? It's not a big monolithic thing. It looks like it from a distance, just like how our software systems and our teams and our organizations look from the outside as just a big monolithic group of, people going and doing finance stuff, right? You make the money go from point A to point B. But when you get down to it, it's a lot of smaller teams, right? And those teams are distributed across the world. They work on different cadences. They work with different sort of priorities. And the system that you get out of that process is not a big, pretty monolith. It's a bunch of like small individual services and decisions made over time that kind of aggregate into this, very beautiful ring. And to understand those systems and understand those services and all the different people involved and all the different priorities, and to actually comprehend it as a human being, you need tools. We love tools, right? Like I have so many gadgets. I have a gadget for everything. I have a gadget that cuts my eggs into like little egg slices. I don't need that. I could just eat the egg whole, but it looks prettier on the salad. So what are the tools that we use for understanding our systems? Well, when we have a big rock and we want to lift that big rock, we use a lever, because the lever multiplies the force that we can apply to that obstacle. Observability is that lever of understanding that we use to make our relatively big brains understand an even bigger and less comprehensible system. And that's why I like to think of observability as like this organizational problem, because when you get down to it, you have multiple sort of areas of responsibility here, right? Like Kelsey was talking about this morning, where there's people that are going up to the third floor, and those teams have different scopes of what they actually do. If you think about your app devs, people working on your mobile clients, they really only care about that stuff up there because that's what they're incentivized to care about. Your central IT team or your cloud center of excellence or whoever, like they're going to be caring a lot more about these sort of lower level concerns, because if this breaks, then everything breaks. And one of the biggest challenges in observability is getting all these people to speak the same language, because their incentives aren't aligned, right? Because the tooling that they use that is customary to them isn't the same tools. And beyond all that, a lot of the problems is that are over here on this standard side, right? Because everyone's data is different, everyone's tools end up being different, right? Like we keep going, and you actually, just to go back a step, like I've seen so many people in so many places kind of go through this, like, okay, central IT or the central platform team is going to come out and we're going to have the new standard that fixes all of the previous standards and aligns everyone into one beautiful data plane. And then 2 years later, it's time for the 16th version of that standard that fixes the problems that we made when we did the 15th version of the standard, right? Like, has this happened to you? And it's because like we don't have a good way to sort of, yeah, you can push these people into doing stuff, but then some, front-end dev is going to come talking about like this cool new, JavaScript framework, and it only speaks in a proprietary format that no one else's does, and they need to go off and spend like 80 grand on some special tool that Cloudflare sells or whatever. these are ultimately problems that derive from the lack of standards. Organizations need standards. Like that's, I'm pretty sure, the driving force in the financial industry is standards, for good reason, because finance deals with people's money, and money is very important to the continued existence of me and everyone in this room on various levels. But it's not just enough to have a standard and a structure for the data. You also need to have data that is highly semantically useful, the data that actually means something, and that meaning has to be self-describing. It's not enough to just say like, oh, this field means this. Like, it has to be reinforced by the standard itself. There has to be ways to discover that meaning. There has to be schemas. You need that because you need this stuff to be built in. If you just go and say, if central IT goes out and says, hey, everyone's going to use this new thing, you're going to have so many problems actually getting that adoption in there, because everyone's, there's subtle differences in region, there's subtle differences in, platform framework. Some teams might be on, Java 7, some are on Java 8, some are on Java 23, some people are using Kotlin, some people are using this, that, the other. Depending on what region of the world you're in, you might have the same applications or workloads or services deployed, but due to various regulatory concerns, this package isn't approved to be used in Mumbai, it only works in London. I'm spitballing, but these are kind of the class of problems you get when you get into like these big multinational organizations. And the way to fix a lot of that is to just push that complexity down, right? It's like, well, what if we didn't have to do all this ourselves? What if it was just part of the framework? What if Spring or whatever else just spoke a standard way of telling me about what's going on in my software? Which leads to the third thing you need to really enable organizational observability is you can't just have something that only one vendor supports, right? Like, you have to have something that works with how you're doing things now. A really fun story that I like to tell is from an old boss of mine, Ben Siegelman, goes by BHS, and he was he worked at Google for a while, and he was one of the people that created Dapper. Dapper is they still use it, I believe, but Dapper was one of the first wide-scale distributed tracing software in the world, and they deployed this back in like 2002. And the goal was to understand, like, hey, Google has this huge microservices architecture, huge at the time, certainly. What's going on, right? Like, when things fail, why are they failing? We can't just like grep across 10,000 edge servers. So they built Dapper as a way to do this, and what he found was he built this cool thing, he shipped it, and nobody used it because everyone already had their dashboards. Everyone already had the way that they diagnosed and debugged these issues. So he talked to one of his mentors there, and he was like, well, why don't you make it easy? Put this somewhere that people already are at. And so they went in and they added a single link on kind of the existing internal service dashboard for every Google service, that when you put in your correlation ID or you answered your Actor alert and you went in and looked at the dashboard to see what was wrong, there was a new thing that popped up that says, hey, look at this transaction in Dapper. And you click it, and it would take you over into a distributed trace that showed you every single server involved, right? From the, where it hit the CDN all the way down to the database and back. And overnight, Dapper exploded in popularity. People are like, oh my God, this is the best thing ever. And it's that kind of extensibility that you need to get things into existing orgs, because you can't just come in with the new tool or the new, this fixes everything flag and say, use this now, because everyone's already used to doing it the way they're doing it. You have to have something that kind of works with what is working today. Otherwise, it's not going to get the adoption you need to really be the foundation of what you're trying to do. And I think that segues into this idea of practices really nicely, because it is great to be able to say, hey, here's this standard that's going to solve all of our problems with, making sure we have highly structured data that's semantically useful, that's built into our runtimes or built into our frameworks. But if you can't figure out how to operationalize it, if you don't have the right tools and you don't have the right techniques to take that data and do something with it and really help people solve problems better or give people more insight into what's going on when there are problems, then it's not going to take off. And that leads to this last thing, and this is the hardest part, which is organizational agility. When you start making changes, people are going to push back. Like I used to work in a .NET shop, And I remember I was kind of leading our DevOps team, and I went and I was sitting down with one of our pretty senior developers, and we were migrating from this kind of old, busted, way of doing integration tests to a new cloud-based one where we could spin up an entire environment in the cloud every time. And I'm sitting down and I'm trying to teach this guy about not Terraform, not Puppet. What's the other? Ansible. Trying to teach him about Ansible. And like 10 minutes into my explanation, I look over and I realize that he's just kind of sitting there with a blank look on his face. He's just like staring at the screen because I'm typing, in YAML or whatever. And I don't think he had ever seen YAML until that moment. And I'm like, hey, I feel like I've lost you here a little. And he kind of stops. And he's like, yeah, nobody ever trained me on how to do this. And I'm like, do what? It's like this, like the YAML. Like nobody ever taught you how to type into a computer? What? And we explored a little bit, and it's like his way he approached work was very different than the way I approached work. He approached work as he comes in at 9 a.m., he opens Jira, he grabs the first ticket assigned to him, he pulls it over, he fixes the ticket, he tests it, he puts the ticket into the next column, and then he grabs the next ticket. And he does that every day for 40 hours a week. And at 5 o'clock, he leaves work, and he doesn't think about work until 9 a.m. the next day. God, he has, and now I think, oh my God, he had such a blessed life. That guy was living. I didn't realize, because this was like my first real software job. I was like, no man, you aren't reading like Hacker News? He's like, what? But you do, but that's the default, right? What I've kind of learned since then is that people that are out here thinking on the edge about this stuff, like we really are in a lot of ways, atypical. And we need to be able to figure out, okay, how do we take the guy that just wants to like pull the next ticket and do his job and enjoy his family time? Like, how do we make sure that we can kind of ease him into this beautiful new standards-based future that we're all dreaming of and this beautiful observability world? And these are changes that aren't necessarily ones that a standard will give you, but they are ones that the standard can help you unlock in your org. And that is why OpenTelemetry, like those are all sort of the motivating reasons for OpenTelemetry to exist. Fundamentally, observability, the default dictionary definition, right? Observability is the way to understand a system based on its outputs. But what I think it really gives you is a way to understand your complex system, but also a shared language to kind of describe that system and to talk about reliability and to talk about what matters with your software and with your teams. Building that capability isn't something that just an agent is going to do, right? You're not going to be able to pop in the OTel agent or any piece of software and suddenly get, a shared language or, more empathetic on-call schedules. Not that you necessarily need those things, but again, these are desires. But we need all this to kind of work together. It needs to be blended. It needs to be harmonized. And I think a way to think about that harmony is to think about observability in a slightly different way than I find most people do. Like, who's heard of the idea of 3 pillars of observability? Metrics, logs, traces, right? That's what you jump to. Rather than pillars, I like to think of it as a cake. Mostly because I'm on a diet, but I think it's a better way to kind of internalize this model. If we think about observability not as raw data and taking that data and doing something with it, we think about it as these layers where we start at the bottom with telemetry data. And this is, what's actually going on. There's a ton of this. Think about, any system that you work with, you are dealing with petabytes, terabytes, multiples of all these things in a day of operational data about like what's happening. And that data comes in a lot of different formats. It can come in the form of a human readable log. It can come in the form of a metric, a time series metric. It can come in the form of a distributed trace. It can also come in the form of like a profile. It can come in the form of user analytics or business analytics, right? Things like segment or A lot of different custom formats. It can come in network flow logs. It can come in load balancer logs. It can come in, right? Like, if you really think about, like, oh my God, there's so much data about our systems that's being generated, and we are usually only looking at like this very small stream of it that's kind of relevant to us. So we actually have a lot of duplication of telemetry in our systems today. And that is why pipelines are important. Because you have all this telemetry, you need to do something with it. You need to process it. There has to be something that takes that first cut and says, okay, let me sample out stuff that doesn't matter. Let me filter out things. Let me hash this PII, or check to make sure that someone isn't sneaking social security numbers in here, or push it off into a security system, right, to SIEM. Pipelines are super important. They're what helps us make sense of all of this raw data and get it in a format where we're ready to take it and store it. There's a lot of different ways to store telemetry, and you don't necessarily need to even store it all in the same place based on its signal type. Like, there's a lot of different reasons that you would store telemetry, right? And there's reasons, obviously there's regulatory and compliance concerns. So, security teams want to keep stuff at a different resolution than other teams for a different period of time. There are business reasons, from a forecasting standpoint, like I want to be able to keep these metrics at a certain resolution for so often, and then I want to reduce that over time, but I still want to know if I want to go back 5 years to see what's happening in terms of my spend or in terms of memory or CPU utilization, so that when the next time I go out to do contract negotiations for data center expansion, I know hey, this is how much I should think about buying in terms of new hard drives, as an example. Once that data is all stored somewhere, you got to query it. Usually these query methods are very tightly coupled with the way the data is stored. There's a lot of optimization that kind of takes place at this query and storage layer. And this is one of the biggest challenges, I think, actually in observability systems, because I actually see these as very disjoint. Like, the way that you want to, your query engine should actually probably be kind of agnostic to your storage layer, right? If you think about it, because I might have, for example, I want 100% of data for an hour, and then after that I want to compress it, or I want to reduce some of it, and I want interesting things that maybe are available for 3 months, and then I want to reduce it again, and I want some other stuff, then I want it to be available for so on in hot storage, but maybe cold storage, I want 100% of things to be available for a year. And I want my query engine to be able to say, okay, I need to go look in both of these places for that data, right? So that's why I separate these in my model, because they are different. And thinking and tightly coupling your query and storage layers together mentally actually can lead you down some unoptimal paths. I also keep projections separate, because the way you query the data and the way you visualize that data is kind of independent of the query itself. You can write a metric style query across log data or trace data, right? These are what projections are available are mostly a function of whatever layer you have doing this. And this is not how we typically think about it, because the way we think about observability tools today is often very monolithic. You go and you get your Datadog, or you go and you get your Grafana, or whatever, and it makes these decisions for you. But for reasons we'll talk about in a few minutes, I think it's really helpful to think about this stuff as modular, especially if you're in the role, if you're thinking about this at a big scale, where you're not necessarily just getting something off the shelf, you're going to be building your own platform. Thinking about these things separately actually helps you a lot with your decision making about how to approach each of them. And finally, you have the workflows, the actual work that gets done with all the data. This is your alerting. This is I go in and I look at the trace. This is your log search, your security alerting, whatever. This is all the way at the top. And that is not to say that it is all the way at the top, because it is both the most and least important thing, right? If you don't nail this, then nothing matters. But at the same time, if you don't nail all this stuff down here, then you can't have good workflows. So why OpenTelemetry? Why is it, what are the 4 big points here? It's a single standard. It's universal. Rather than looking at data as these disconnected pillars of metrics, logs, traces, we turn them into a single braid of highly correlated data. We give you semantic conventions that give meaning to that data, and we give you a single wire format called OTLP that also works with your existing data, right? So you can gradually move a system towards OpenTelemetry. From a visualization, if we want to visualize this a little bit, I have my nice little OpenTelemetry demarcation line right here. And if you look back to the model, you'll see here's the parts of our model. So the stuff over there is all OpenTelemetry cares about, right? We don't make an opinion about where you store OTel data. We don't care how you query it. We aren't going to lock you into a given workflow or a given way of projecting that data. All we care about, we are 100% laser focused on the telemetry data itself and the pipelines that help you modify it and get it ready to send it somewhere else. And I think this is the primary reason that OpenTelemetry has been kind of successful up to this point, right? Because we're not coming into, any vendor's house and saying like, hey, here's how you have to do your stuff. We're saying, hey, here's really high quality data for you to build on, and then you can take it and run with it. A couple of, definitions and just points to talk through. I do want to leave time for questions. At the end of the day, your telemetry is coming from instrumentation, and instrumentation is the code that produces telemetry data. That can come from any number of sources. At a really low level, we kind of think of all this stuff as just like events that are happening in your system, and then you transform them into some structured representation of that event, and then you give it semantic meaning through semantic conventions. And it's not just performance data. You can also do this with user analytics. You can do this with really anything as long as you want to go and create sort of the semantic representation of it. In the middle for our pipelines, we have one thing called the collector, but people could write more. But this is your Swiss Army knife, right? This is what is getting all of your node metrics, host metrics, whatever. It's also where you can kind of take existing data and convert it into OpenTelemetry format through receivers and processors. And it's replacing the functionality of a lot of like the traditional sort of agents that we think about, right? So if you think about like the Datadog agent or New Relic or Grafana, whatever, like the collector is taking that place. And what we're seeing in the market right now is a lot of people, like the Grafana agent, they renamed it, but it's basically a collector with a couple things slapped in there. Dynatrace has a enterprise supported version of the OTel collector. So we're seeing New Relic is also standardizing on OTel. So we're seeing a lot of the existing vendors in this space kind of come around and say, hey, we're just going to work with what's upstream and not kind of create our own thing, which I think is good for all of you because it means that you have more vendor agnosticism and portability. Again, we don't have much of an opinion about those first two layers. There's definitely some tools that are better at working with the OTel data because they're built more around that model of like a correlated stream of data versus three pillars. But there is a lot of really cool stuff you can do with it, right? Like one thing that I've been talking to some people about is taking the sort of thinking we've had about like data lakes and just big data management in general and applying that to observability. Because at the end of the day, it's kind of the same problem. You have a lot of data. How do you make sense of it? Well, rather than kind of saying, okay, we're going to send this stuff here, that stuff there, it's like, well, let's send it all to a big data lake that we manage, and then we can kind of take little parts of it off and put it in the right tool based on our user needs and what our teams are trying to accomplish. You can also use it as a really nice wedge to sort of do, if we remember our 15, 16, 17 different, central IT standardization effort, OTel is actually a really great wedge for that because you can just deploy a collector that does that conversion for you without having to require people to change a lot about what they're doing. And OTel has this concept of schema. It's very schema driven. So there's a concept called telemetry schemas, which let you actually define your own transforms between like version 1 and version 2 of a given set of output telemetry. So you can kind of do these nice staged upgrades where instead of having to boil the ocean, you can just deploy some stuff and just slowly kind of roll it out without breaking existing dashboards. And then when things upgrade, you also don't break the new stuff, which is nice. You can compose the SDK or the API with existing internal frameworks. I've seen a lot of people do this. You have your own structured logging framework or your own microservice framework you're using. Cool. You can embed OTel API into it and then just write the conversion, just write a little wrapper so that your existing telemetry API will speak to the SDK, and that way if you pull in a third-party dependency that's using OpenTelemetry, it'll kind of work with what you've already got, which is nice. We have Weaver. I was talking about schemas. Weaver is the tool that helps you do this. So you give it a set of, you give it a YAML file basically, because we are in the CNCF. We love YAML. No? Okay. That plays better at a KubeCon. Anyway, you hand us a YAML file, and we can do things like code gen for you. So you can actually create a client that has all of your semantic conventions for your internal services, which is nice. We also are working on something called OpAmp, which is agent fleet management. So you can deploy a collector or 1,000 collectors or 100,000 collectors and then have a single open source way to kind of get the health of those, push configs, handle updates, so on and so on and so forth. Just to wrap up real quick before questions, a few people that are using this, Jack Henry has adopted OTel, and they're big tracing users, so they've been able to kind of use that really high cardinality data to really quickly narrow down and find problems affecting specific users. Vanguard standardized on OpenTelemetry. They were actually a very early adopter. They started like 3-4 years ago, and now they've kind of deprecated all of their legacy APM and have also used that as a really cool way to adopt SLOs across their engineering organization, so that they're able to kind of find problems before it actually impacts customers and fix them. Finally, Move, they do like payment rails and stuff like that. You'll forgive me, I'm not a financial person. But they do payment rails and stuff like that, and they're able to kind of, again, use that high cardinality tracing data from OpenTelemetry to really understand, as requests come across their API and they're bridging multiple different, third-party systems, which one of those is having problems, right? And use that for both SLA compliance contractually, but also to understand like which one of their customers or their customers are maybe having problems. So that's my talk. I think we have a few minutes for questions, if I'm remembering correctly. Yeah, we got like 10 minutes for questions. Thank you. So, yeah. Let me read that one back to you. And let me ask a clarifying question. Do you mean like you have, let's take a trace, right? And I'm have a client, and then that client talks to a third-party API, something outside of my firewall. And so when I make that client request, I am sending an OTel context across the wire to that third party. How do I get their side of the span back? No? Okay, so you're saying like I have a metric in Datadog, and then my traces are in this other non-Datadog thing. Even if I have a correlation context, how do I kind of navigate from one to the other? So just to reiterate the question, OTel gives you this really powerful context, is built on this idea of context. And so whenever you have a transaction in your system, there is a unique ID for every single one of those. And then when you export telemetry through OTel, all that telemetry gets that context. So you could say, I have some metrics, and those metrics have exemplars. Those exemplars are trace IDs of these specific traces. If those are in different places, then your only option really is to have tooling at that sort of like up here, that workflow level, that can help you navigate between them. The other thing to look at, and this is kind of what I was talking about different tools being better or worse at dealing with OTel data. If you use something that just doesn't discriminate against against signal type, and just lets you bring in all this stuff that's kind of events, then it's all in one place to begin with. So like at Honeycomb, we don't actually have like a separate metric log trace store, right? We take OTLP in, and we just, based on what kind of data it is, that does influence some of the query, that kind of influences like your workflows. But like you can just, if you have a metric you're sending us and it's got that exemplar in there, then it's just like you click it and you're, it's right there, right? Or if you're querying for, hey, show me everything related to this trace ID, we will also show you the metrics and the logs at the same time because they're all in the same data store for us. And I think that approach, like not even using Honeycomb, just in general, is going to become more popular because you're seeing stuff like, if anyone's familiar with like ClickHouse, yeah. Like ClickHouse-based columnar data stores are becoming extremely popular, and I think the other thing that will become extremely popular here is simply just document stores, just like putting all this stuff in S3 and then using like an Athena or Athena-like thing to query across it, or Snowflake, right? Like that to me is where this is going in the next like 3-4 years. So, but. It's just that style, right? That sort of like, oh, we're just going to throw everything into like a column store or do OLAP stuff. Like these are problems that we have, I don't want to say are solved, but like literally everyone outside of the observability industry has been doing big data in a certain way for the past past decade almost, and there's a reason why, and it's because it works. So rather than reinvent the wheel, I think especially like large enterprise is going to sort of, I think you're going to sort of see that them lead the way on, hey, this is how you actually deal with this stuff. Other questions? Was that good? Cool. Anyone else? You, then you. Sorry, purple, and then guy behind you. Yeah. Let me read it back to you. So if you have a system where you've got different sort of workloads running, and those are not, so you've got, application, services running, and then you have like queues or data pipelines or something where it's not, where you don't necessarily have like a nice, easy, this thing leads to this thing leads to this thing, like parent-child relationship. You've got more of like a web of dependencies. Yeah. So depending on how you're deploying this stuff, usually the easiest way, if it's like appliances or if it's stuff where you can't easily change the code, is to use something like the OpenTelemetry collector with a custom receiver. In that receiver, you basically provide the collector mappings and you tell it how to convert the existing data wherever it lives into OTel format. The other thing you usually have to figure out is how to get context to those downstream systems or to your existing stuff. There's a couple ways you can deal with this. One way is if you have a consistent way to kind of pass the context of a unique transaction throughout the system, you can write your own propagator. And you can basically tell OTel, hey, this is how we track this already. And then when you add something new using OTel, you can tell it, hey, use our custom propagator. Don't use like W3C trace context, right? Don't use the standard. Use our thing. And then it'll all kind of work together for you. So is that helpful? If you want to ask me, if you want to like sketch it out, like we can, find me later today and we can kind of go through it more in depth. Okay. Is the next speaker here? Yeah. So guy in blue, if you want, you can follow up with me outside. We are supposed to make sure that we cycle through everything. But thank you all for coming so much. And yeah, would love to talk to you more about OpenTelemetry.